everyone. This is a Grasshopper tutorial for how to generate a waffle structure. So to start off here, I have a loft that I made from 3 curves, and then I've just extruded it. So to generate a waffle structure, we want planes that are running through the X and Y of our shape here. So first we're going to add a bounding box. Going to plug our shape into that. And then we're going to scale the box up by a factor of about 1.1. And to get our center, we'll use volume. Oops, wrong one. Center. So from this bounding box, essentially what we want is this side face and this front face, and we want these faces to be cutting through our object. So next what we're going to do is we're going to do a deconstruct brep, and that's going to split our box into its individual faces, its edges, and its vertices. We just want the faces, so we're going to do list item. I'm going to do this twice. And for this first one, we want, it's already automatically on 0, but for management's sake, we're going to add a panel and put 0. Then for a second one, we're going to put 1. Hide those, and then you can see there, that's our front face, and this is our side face. I'm going to group this top one, and we're going to call this one Y faces, or Y face. And then we're going to group this one and call it our X face. Alright, so from there what we want is we want brep edges. And what we're doing is we're going to try to extract this bottom line out of these two faces. So do it for both. Going to do list item again. And that should give us just the bottom lines of the faces. So from there, what we're going to do is we're going to divide curve. Divide this curve, and it's already on 10, but I'll just put it in anyway. And then for this bottom one, I'm going to put about, I'm going to divide it by 12 because it's slightly longer. Okay, from now we have our points, and we want this face to be located at each one of these points. So what we're going to do is we're going to do orient, and we're going to take our Y face, plug it into there, and we know that our ending location, our target, is going to be these points right here, but our initial plane will be this point down here. And there's many ways of getting this point, but I'm just going to do endpoints. Oops. Endpoints for this line. And I believe it's the end, just check. Yep, so you can see it's this point right here. So we're going to put that as our initial, and then where we want it to end up will be these points right here. So take these points, and you can see there it's oriented correctly. And then we're going to do the same for our X faces. So we want the X face, we want to keep the same initial point, and then but our target will be these points up here. And there you go, you can see now we have X and Y planes cutting through our lofted object. So what I'm going to do is I'm just going to group this one and call this one Y planes, this one x-planes. Okay, now that we have planes cutting through our object, we want it to solve the intersection between our lofted object and these planes. So what we're going to do is we're going to do a brep intersection, just type in bbx, and we're going to take A is going to be my original lofted shape, plug that in as A, then we're going to plug in our planes, we'll hide these, copy paste, and then do the same for the x-planes, and let me just hide our original extrusion and then you can see there it solved the intersection, and now we have our shape in just x and y planes. So from here I'm going to do boundary surface to change these curves, make these curves into surfaces. Great. Alright, so from here, now that we have our shape in x and y planes, we need to start making our notches. And to make our notches, what we're going to do is we're going to find out the intersection between there and there, those points, and then we're going to have a cylinder going from the middle to the top, and then a cylinder going from the middle and the bottom, and I'll explain why. So first we're going to do another brep intersection, bbx. Going to do it for our two surfaces, and we're going to graft the first one and flatten the second one, or vice versa, it doesn't matter. You can see here what it's done is it's made lines between the two intersections between all these x and y planes. And now what we can do is we're going to divide curve. We're going to do it by 2. You can see now we have our bottom point, midpoint, and top. So we're going to do list item. I'm going to copy it 3 times. I'm going to add a panel. I'm going to put 0 in that one. And then 1 and 2. You can see now that we have top point, middle point, and bottom point, and we can make this even easier on ourselves. Top, middle, bottom. Great. So from here now, we are going to make a cylinder, and we're going to say that our base will be the middle both times, and the length will be the distance between the midpoint and the top, and we're also going to do addition. I'm going to add, it doesn't really matter how much you add, but let's just put 5. Put that into our length. And you can see now that it's made a cylinder from the midpoint to the top, and then it's also added 5. Now the reason we add 5 is if you see here, when I've got it down to 0, you'll see this cylinder, it goes to the point, but we want the cylinder to go all the way past the curve. So to do that, you can just add, and it actually looks like all I need is about 2, maybe 3, but it doesn't really matter. And we're going to do the same for this bottom cylinder. So distance between midpoint, bottom point, and then sorry guys, it just cut out. Alright, so starting off where we left off, for the bottom cylinder, so we're going to do distance again, same thing, A, E, and then we're going to do negative this time because we want the cylinders to be going in the opposite direction, like that. And then for our radius, we want a 1.5 radius because 1.5 radius is a 3 mil diameter, and 3 mil is the thickness of your material, so 3 mil acrylic. And there we have our cylinders. So from here, what you want to do is you want to cap these off. And we're going to do a solid trim, or trim solid, sorry. We're going to take our planes, so our boundary surface is over here. Copy, paste. And we're going to take our cylinders and we're going to flatten that. And now if I turn preview off for everything, you can see now that we have our notches in our planes, in both of them. And now you have essentially a waffle because you can now orient these and maybe add like a naming system using concatenate to make it easier so you know where each part goes, and then you can laser cut these. What we can do next though is we can extrude these and make these 3 mils for your renders. So what we'll do is we'll move them. These ones are on, these are our Y faces, so we're going to move it 1.5 in the Y direction. And we're going to do that negative as well. Oops, actually I'll do it the other way around. I'll do negative 1.5 Y direction. And copy paste. Do it for the Z direction on the other ones. Turn all these off. And then we're going to extrude these ones in the Y by 3 because it's 3 mil acrylic. Extrude these ones in Z direction. Oh. Z. And that should be it. And this is ready to bake out, and then you can do your renders. Just to be absolutely sure that we've done it correctly, what you can do is you can add a move to the top one, so this one. We'll preview off. We'll do Z direction, and we'll do 50 maybe. Yep. And then we can see there that if I move these down, they should slot in correctly. And there you go. That is the finished tutorial for your waffle structure. From here you can try exploring more complex shapes because this was a very simple loft. Or you can do more complicated ways of waffling, such as a radial waffle, which goes in a circular motion rather than just going X and Y planes.